be finding the area of parallelograms and triangles. Let's take a closer look at these shapes. Here's a parallelogram. We know this is a parallelogram because it has two sets of parallel and congruent sides. We find the area of a parallelogram by multiplying the base by the height. Does that sound familiar? It's the same formula used to find the area of rectangles. How could that be? Well, think of a parallelogram as if it were a slanted rectangle. You could even take a piece of the parallelogram and move it around to make it look just like a rectangle. We didn't change the amount of space the shape takes up, but we did change what the shape looks like. That's why the area formulas are the same. Then we have triangles. Notice that some triangles look like half of a rectangle. That's why we can find the area of a triangle by multiplying 1/2 by the base and the height. Now let's try some examples. Here we want to find the area of the parallelogram. Remember, the area of a parallelogram equals the base times the height. The base is 18 and the height is 36, so we'll substitute those values into the formula. 18 times 36 is 648, and since area is measured in square units, the area of this parallelogram is 648 square feet. Moving on to example 2. This time, we're given the area of the triangle, 168 square centimeters, and the length of its base, 16 centimeters. But we're asked to find the missing length, t. Note that t is outside the triangle, but it spans the distance from the base to the triangle's highest vertex and is perpendicular to the base. That means t is the height of the triangle. Recall the formula for the area of a triangle equals 1/2 times the base times the height. Since the area is 168 square centimeters and the base is 16 centimeters, we can say that 168 equals 1/2 times 16 times t. 1/2 times 16 is 8, so 168 equals 8t. We can solve for t by dividing both sides by 8. 168 divided by 8 is 21, so the height of this triangle, t, is equal to 21 centimeters. Great! Here's example 3. This time, we want to determine which figure has a greater area. We have one triangle and one parallelogram, so we'll need to find the area of both to compare. Let's start with a triangle. We know what to do. The area of a triangle is equal to 1/2 times the base times the height. So we'll substitute 71 for the base and 58 for the height. Now we can multiply. 1/2 times 71 times 58 gives us an area of 2,059 square feet. Let's find the area of the parallelogram next by multiplying the base and the height. 52 times 46 gives us an area of 2,392 square feet. Now we can compare the areas. Since 2,392 is greater than 2,059, the parallelogram has the greater area. Let's try one last example. We're told to find the area of the parallelogram. This time, we have polynomial side lengths, but don't worry, we can still use the same formula to find the area. Since this is a parallelogram, the area is equal to the base times the height. The base is x plus 9, and the height is 3x, so let's substitute those polynomials into the formula. To simplify, we'll need to distribute the 3x. 3x times x is 3x squared, and 3x times 9 is 27x, so the area of this parallelogram is 3x squared plus 27x. Great job today! Now get back out there and keep practicing.